Hi everyone. I'll be taking a small session today on exploratory data analysis, which you will be using in your project if you are working on any ML based or data science, ML based project. So let's get started with that. And this is the overview of what I'll be covering today. The topics, it's why EDA, steps involved in EDA, and we'll be discussing with an example. So if you have already started with, even if you have started with replicating your Q2 project, then a lot of things that I'll be discussing you might have either encountered once or twice, now, or you'll be doing it in the future. So let's go ahead and see what all we have. First things I want to start off with, what should be included in your report. So you'll have to submit a report by the end of your Q1, and in the report that you'll be submitting, there is no need for you to include all of the EDA. You'll have to only include those portions that are relevant and that give an idea or give the context of the kind of questions that you're trying to solve. So, and after performing it, you'll have to look at the data and see if the data is capable of answering for a few questions, like for example, like you have performed EDA, you have probably removed a few data tuples and you have done some data analysis, you've probably eliminated a few columns, and at that time you're performing the analysis. So you'll have to see that the transformed or the reduced data set that you have, is it really helpful in answering the questions that you want to answer, in predicting whatever you aimed on predicting in the first, and then the transformation techniques or the cleaning techniques that you performed or that you applied, like why did you really do that? Like for example, let's say you have text data and you wanted to, you just stripped out a few white spaces or the new lines or some emojis or some numbers or something. Why exactly did you do that? Why was it not adding value to the, to your model or, to your analysis? And why does the data support your modeling decisions? Like for example, the data that you have and you have applied a model, are they really related, or does this model give the best results for this type of data? So on and so forth. You'll have to answer a lot of questions, and I think those are the points that you can, those portions of data analysis, rather, it is very good if you include it in your report. And then the problems, like there were a few problems with the past reports, and the common problems are, okay, so for example, the person who will be looking at your project for the first time or looking at the code, they'll be not knowing what your data set is. So giving them some context on it, like in 1 or 2 lines, is very helpful, rather than rather than summarizing the entire data set. Like for example, you can there is the method in pandas, data.describe, which just lists the type of data and the number of columns, etc., etc. So doing something like that will help the person who is looking at your code for the first time to get insight about your data as well, and they'll not have to go through the entire data. So that is something you can do. And yeah, that is again told for images and for text. So you can use word clouds to show the number of, the type of words, that the different words that are present in the data, etc. So for plots, a lot of plots are blurry and it's not good to submit those plots. So you can increase the DPI, you can save it in PDF. And then the few mistakes that you should definitely not do are not introducing the data and describing how it's collected. So it's possible, if you're following all the techniques that are mentioned in the last methodology lectures as well, you'll be having different folders and you'll be writing the code to extract the data in one folder. You'll be actually keeping the data in another folder, and your data analysis file will be in another notebook folder or something like that. So at that time, making sure that you're describing how it is connected, how we are going from traversing from one part, from one folder to the other folder to collect the data, and what is this code doing, what is this, including those relevant comments and descriptions, that's going to be really helpful. And then the describing the data cleaning process, like whatever data cleaning that you're doing, why you're doing it, why do you think that cleaning it in this way is essential, including that, and justifying your model choices. All these are something that you should definitely do it in your report, and not make these mistakes by not doing it. So Tukey, he's the person who authored the exploratory data analysis, and he has given this quote. Let me quote him. He has told, in exploratory data analysis, there can be no substitute for flexibility, for adapting what is calculated and what we hope plotted both to the needs of the situation and the clues that the data have already provided. So from the, from the quote, we can see that he's kind of like stressing a lot on flexibility, saying that there is no substitute for it, because often it happens that you get along with the project, you do a few data analysis, you plot something, and then you think this is not really what you wanted, or this is not really serving the purpose, and then you go back and you do some reverse engineering, you make some other changes, you think some other variable or some other data point is giving having a lot of significance, and basically, to just summarize in one sentence, you should have an open mind throughout your project. You should not just be fixed that you're going to just consider these variables and they're going to give this results. No, you should have an open mind, and you should be, you should accept those changes and evolve with it while you're performing the project. So why EDA? Can any one of you like give me 1 or 2 points in this, like why exactly EDA, what does EDA do, or why is it important? Yes?
Gives like a feel for the data.
Gives them, sorry, what?
Like a feel for the data.
Like a feel for the data, yeah. Like you look at it and probably you can get insights about the data, and you'll be able to have a better understanding of it. That's one good answer. And so these are all the few points on why EDA. I'm going in the reverse order, like, okay, so detecting outliers. It often happens that when you either generate a scatter plot or a histogram or anything, there might be a few data points that are lying very far away from the rest of the data points. And if you have a scatter plots, if you have divided into two groups, say blue and yellow, and there is another data point that is like that does not belong to either of these cohorts, and it's staying very far. So that time there are like two questions, right? How do you exactly plot the data? Like, do you change your line, the classifier line, so that you include that point that is far away, or do you just ignore it? Okay, do you remove that data point from your sample? So that's like the trade-off. What is necessary? What should be done in that situation? So all these questions, it varies from the data set to data set, and the answers that you choose will also be dependent on that. So that is why EDA plays an important role over here, because it helps you detect those outliers. It helps you understand the patterns of the data. So is the data highly skewed? If there is is there a direct relationship between these two, this variable and the outcome, so on and so forth. Like, you can get the feel of the data, as he told, by understanding the patterns. You can identify the errors, like when you plot the data, if there are a lot of NaNs, or null values or something like that, if there are a few values that are missing, that you can do all those things. You can perform various statistical analysis, you can compute the mean, median, variance. You can see how the data is either converging at a point, diverging from a point, etc. So all these come under EDA. Steps involved in EDA. You can basically may have a lot of steps, but I have summarized it into 3 steps. The first one is extracting the data, data pre-processing, and exploratory data analysis. So while performing each of these steps, there are a few questions that we have to keep in our mind, and we'll have to ask those questions whenever, so for example, when you're extracting the data, there are a few questions that we'll have to keep in our mind and make sure we are addressing those questions when we are following that step. So let us keep it interactive. Let me see if you guys can come up with a few questions that you think are important to answer when you're extracting the data. Anybody? What do you have to keep in mind when you're extracting the data for your project? Yes. Yes, so that is one of the important factor to look into. So for example, let us say a lot of data, it will be in a semi-structured or unstructured format, but you want it in a structured format for your analysis. So at that time, you will have to see if that is the only format in which the data is available, or is there any other source from which you can get the data in a formatted, in a structured format. You'll have to also look at the source of the data. Like for example, it is possible that often the data that you get, there might be a website that is not really reliable, and do you really have to extract data from that website? Is it trustworthy? So the source of the data matters, and the type of the data. again the format, and then maintaining consistency. Like for example, for your project, it is you might often you'll often extract data from multiple sources, and it is possible that in one source the data was in this format, in the other source it was in this format. So you'll have to, when you're doing your project, you'll have to make sure the entire data is in one format. So you'll have to maintain that consistency. All these things are a few important questions that you'll have to keep in mind when you're extracting the data. And next, going with data pre-processing. So can anybody guess what are all the steps involved here? What all questions do you have in your mind you have to keep while you're pre-processing your data? What all you should be vigilant about while pre-processing the data? Yes, yes. Is the data tidy? Yes. So like, does it have like a lot of duplicates or missing values? Yeah, that's true. That's a good point. Yes.
What is the desired format data?
Yeah. Yeah. So the thing is, like, if you don't have it in your desired format, then you'll have to transform the data into some other format. And at that time, again, you'll have to answer a few more other questions. Like, for example, if you're looking in the structured format, and if you're trying to join data from different sources, then you'll have to see if, if it's a database, if it's a SQL or something like that, then you'll have to see if the primary key over here is the same as the primary key over there. What exactly is the condition that you can take for joining? How exactly do you handle the missing values? Yeah. So all these things are the important points in the data pre-processing. As like, just to summarize, format of the data, that is important. If the data types are compatible, so for example, like, if you want, like, sometimes you might want some data to be present in integer, but it is in string, or, in some other value. So the data types are not really compatible, or if you want to predict something, but that's again stored in some other format. So all these things matters. And then joining the data, as I told, if you have it from multiple sources, what exactly is the joining condition that you can give in order to join the data, right? Handling the missing values. So it is possible that a lot of times all the data fields are not populated with values. There will be a lot of NaNs or nulls. So how do you really handle those missing values? That is again a trade-off question. And then the data reduction. Okay, so next, the main part, the core part of the presentation, exploratory data analysis. So exploratory data analysis, here you can perform statistical analysis. So there are various ways you can do it. So histograms, scatter plots. It is possible that, whatever, like for a particular type of data, for a particular problem, scatter plots are the best fit. But for some other type of data, for some other problem, it is mainly histograms. And then one of the major point to remember during your EDA is for outliers. You should always check for outliers, and you should also see how you can handle those outliers. What is it that you have to do? So sometimes it is possible that you'll have to normalize the data to handle those outliers. Sometimes you'll have to just remove those outliers. So again, it is question specific, the data specific. Just keep it in mind. Watch out for all these things when you're performing your EDA. Okay, so now we have two examples. The first one is about the automobiles. So let's assume that we have a data set related to automobiles, and we have to solve one question. So this is the potential question, that is, we'll have to predict the fuel consumption of an automobile. So what do you think should be present in our data set? Like, what are the data points that our data set should contain so that we can make this prediction? Yes?
The miles per gallon of the car and the miles traveled.
I'm sorry?
Like the miles per gallon.
Yeah.
And the amount traveled.
Okay. Anything else? Okay. Yeah. Yes. Got it. So that, yeah. You had something else?
Maybe like other factors like weight, like displacement.
Yeah. True. So all these are like the important data points that are needed, right, in order to ensure that you will be able to predict the fuel consumption. And also there is one more thing. Okay, so this is one more thing before we go with the variables of interest, that is the data points, the good qualities of a data set. So as I told, the source of the data set is really important. You should ensure that whatever data you are collecting is from a reliable source. So if you collect the data from not so reliable source, then even the predictions that you make will not be able to generalize those predictions, or we will not be able to say, hey, so if the car is of this make and this model, this type, blah, 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 then it will have a higher fuel consumption. We cannot say that unless and until we can completely trust the data on which we are doing our experiment. So to talk about the variables of interest, as you guys told, for fuel consumption, a lot of these variables can be explanatory, like make, model, type of car, engine size, number of cylinders, age. Like for example, if the vehicle gets older and older, then it will obviously not be that efficient, and the mileage will decrease and all those things. One more thing that I wanted to tell over here is that when all these variables are explanatory, it is possible that the data set that we have has some other non-explanatory variables. Like for example, there is the color of the car or color of the automobile present in the data set. So it is, you don't really get to know the fuel consumption of the vehicle based on the color of the vehicle, right? So at that time you can entirely delete that column if you think it's not going to make you any difference for you, right? So those are some things that you'll have to watch out for as well. And yeah, so this is it, and this is the data that is collected from the Government of Canada. And over here, so you can see, this is the df.head that is giving us an idea about the data set, what are all the different rows present in our data set and the different columns. So the data cleaning, we are generating histograms to see the, the number of cylinders and the engine size, and we are seeing the distribution of each variable to see if we can match the, if that matches with our intuition. And we are also looking at the, how can we handle the outliers, like, if we have to replace it with the mean or the median, etc. And like, it's possible, that's one of the ways to handle the outliers. We can also perform cursory analysis to see any trends. Like for example, if there are more number of cylinders in the car, then does that directly mean that the fuel consumption will be more? So that is one of the questions, and you can investigate it, you can investigate the trend, you can do a plot and see how are they related to each other, how are these two variables, the fuel consumption and the number of cylinders, related to each other, right? Yeah, so use box plots, histograms, correlation plots to guide your analysis. This can help you motivate, justify your modeling decisions. So you can just say, why did you choose this model, or why did you go ahead with this? Because like I generated this plot and this is how they are related. I could tell that, and that's why I thought this is the apt model to apply. This is the decision that I had to take. Okay, so now we have the next one, that's the births of babies. So before we go for the potential question over here, can anybody guess what like if we have a data set consisting of like the births of babies, what are all the questions that we can ask based on that data set? Like if you just, yeah?
The date.
I'm sorry, the date of the date of birth, okay. Okay. Anything else? Okay, so over here there's this interesting question, like, if this is the birth of the babies, the potential question is, are firstborn babies more likely to arrive late or early? So, if you are the firstborn child, then it's, is it likely for you to be born earlier or born late? What do you think are the factors that influence it? What are the good data points, the good variables that will guide us to make this prediction or answer this question? Yeah.
The amount of time pregnant?
Yeah, the length of the pregnancy, right. Anything else? So I think even the health of the mother will matter, because if the mother is not feeling too good and if she is not really able to keep the baby in her womb for like 9 months or something, at that time also it's possible that the that is affecting the arrival of the baby, right? And the age of the mother, even that matters. So again, qualities of the good data set, what do you guys think would represent a reliable and reliable sample? from which source should this data set be, so that you can trust the data set. Yeah? Hospital, exactly. So if it's from a hospital, you know you can trust the data set, you know it's from a reliable source. So that's it, and then there is the standard method of collection and the variables of interest. Yeah. So there will be other factors also, like the demographics, the time of the year, the birth weight, age of the mother. So it's possible that a lot of times when the baby is born early, like for premature babies at least, the birth weight will be very less, like, you know, it is lesser than the normal birth weight that is, you know, expected of the baby to be. So those things can also sometimes play a deciding role. And here we have collected the data from CDC and National Survey of Family. So these are all the data of, you know, variables that we have. Okay, so this is the distribution. Do you guys see anything in this plot that is, you know, kind of like off or something, like, yeah?
There should be more bins so you can see the distribution that it's moving.
Okay.
Like everything from 0 to 10 is all chunked into one, but if you divide them
Yeah.
by each number.
So the distribution will be more, you know, it is over a few bins. That's good. Anything? Yes?
You're probably not going to have 80-pound babies.
Yes, we are probably not going to have an 80-pound baby, and we are definitely not going to have that's an outlier over there. So I think that outlier is just to, you know, demonstrate that concept. So we have like the, you know, nearly 100-pound baby, and that is impossible to have it. So in such cases, when you have such data sets or such data you know, samples that are like outliers, how do we handle the birth weight? So over here, what they are doing is they are just taking those that the birth weights is like, you know, the normal, it's just, it should be at least 20 pounds. That's what they are assuming, and they're taking those, only those samples that have the birth weight greater than 20. And yeah, they have you know, increased the number of bins, and you know, in that case, by removing the other data samples, it is like normally distributed as well. And yeah, you can perform cursory analysis to, you know, see the pregnancy length and the birth order over here that is being plotted. And you can also answer this using the t-test, and yeah, so this is the answer over here, and this is the statistical plot. Okay, so this is it for my presentation. I will, you know, if you guys have any doubts regarding EDA, then I'm here, I can